this lesson, as you can see, we're going to talk about the area or the surface area of cylinders. So the first thing I want to look at are all the pieces of a cylinder. And the first one I'm going to look at are the circles that make up the cylinder. Those are referred to as the bases, similar to the bases in a prism. They're going to be both parallel and they're going to be congruent. I'm going to look at the red segments here. The red segments are referred to as the axes. The cylinder will spin around those two. And then the purple, that's going to be the height or the altitude. Now the other part is, this is a specific type of cylinder and it's referred to as a right cylinder. And the reason it's a right cylinder is because the axis is perpendicular to both of the bases. And then over here, this one is referred to as an oblique cylinder because the axis is not perpendicular to the two bases. So keep that in mind. Most of the time we're going to be looking at the right cylinders, but there will be an occasional oblique cylinder that's going to show up there as well. So remember that vocab. The altitude or the height is going to be very important to what we're going to work on, and the bases are going to be very important as well. Now I want to take a look at the net of a cylinder, because I think if I can draw the net, I'm going to be able to find the area of those pieces. I can add them all together and I'm going to have my surface area. What I want you to think about is a soup can. And if you were to take and peel off the label of the soup can, what would it be? Most of you are thinking right now, it's a rectangle. And that is correct. So right here, I think of that as that's the part of that wraps around the cylinder. And then you have those two circular bases that you have to put on. Well, you're going to have one that'll be here, and then you'll have one that's going to be down here. And these should be touching at one point the rectangles. Now sometimes your circles may be over here. My circles are too big to draw here and here, but in a case like this, you'd have kind of the tall, skinny cylinder. This one's going to be a little bit more on the shorter and wider side. So it's all going to depend on the dimensions of the cylinder as to exactly what it's going to look like. But in general, that's what the net of a cylinder will look like. It's always going to be one rectangle and two circles, as long as it's closed. Well, then I want to look at finding the surface area of my right cylinder. And I've given you dimensions of r is the radius of the circle and h is going to be the height of the cylinder. So what I'm going to do is I'm going to come back here and I'm going to steal this net. Because if I can find the area of all those pieces, I'm going to have it. So I copy that, bring it over here, and then paste it in again. So I put my dimensions in. It tells me that this is r, and it tells me that this is h. And I know that that part is h right here because h, remember, the height of your cylinder is the distance between the two bases. It would be the same thing in a prism. The height of the prism is the distance between the two bases. Now I can look at this, and if I can find the area of my circles, I have part of it, and the area of the rectangle, I'll have my entire surface area. I'm going to look at my circles first. So the area of my circles, pi times the radius squared. Well, I called the radius in this r. There's the area of one of the circles. There's the area of the other circle. So I have the two circles. Now I just need to find the area of the rectangle. Well, I look at this and I have the height. The only problem is I don't have the length of the base. To find the area of a rectangle, I need to do base times height. Well, if I look at that base and I go back to my soup can and put the wrapping back on it, if you look at this piece right here, you're going to notice that as you wrap it around the cylinder or the soup can, this part right here is going to wrap around the circular base. And if this is wrapping around the circular base, that means that it has to be the circumference. Therefore, this length right here is going to be equal to 2 times pi times the radius of the circle, which in mine I said is r. Now I know the length of the base, I know the height, I can find the area of my rectangle. So for my rectangle, I'm going to do base, which is 2 times pi times r, and then multiply it by the height of my rectangle, which is the height of the cylinder. So when you look at this, these two pieces are the two circles, and this is the rectangle. Now if I do a little simplifying here, I see I have pi r squared plus pi r squared. Well, pi r squared plus pi r squared is 2 pi r squared. So there's the two circles, and then I have to add on my rectangle, 2 pi r h. And this is going to give you the surface area. I use SA for surface area. I know some books will use T, but that's not a real big deal. So the surface area formula, if you want, is right here for a cylinder. I'm a firm believer in the let's draw the picture and find the area of the pieces, because I have two circles and a rectangle, and I already know how to calculate the areas of those things. But if you want one more thing to jam into your brain, there's the formula to find the surface area of a cylinder. And that's going to conclude the lesson portion of my surface areas of cylinders.